2, 1. Okay, the next thing in calculus we're going to take up is a continuation of many of the concepts we've had in chapter 2 so far. Topic today is horizontal tangent lines. And what we're going to do is we're going to take a look at the function, its corresponding graph, and we're going to predict where, at what point, you're going to find one or possibly more tangent lines that are horizontal. Now, what is true about horizontal tangent lines, or horizontal lines in general, is that the slope, which is y prime, which is the function or the derivative of the function, that value is 0. We've shown this a couple of times in previous discussions about this. And this is going to be what we're going to set our derivatives to. And then we're going to solve for individual values of x that will satisfy that. And then we'll use the original equation y or f of x to determine what the actual points of location are on the graph where those horizontals are going to be. So, we're going to take a look on page 116, and we're going to start with problem number 53. We're going to go down the odd numbers there for 5 problems. Give you some practice. So the first 3 are going to deal with this very idea here, and then there's a variation on the next one that we'll talk about after that. So for number 53, the equation they give us is y is equal to x to the 4th minus 8x squared plus 2. And we want to know what points we're going to find the possible horizontal tangents. Now, just a quick overview. This is a 4th degree equation, which means that one of 2 possibilities exists as far as finding horizontal tangents. We can see as many as 3, because when you have a horizontal line that and has a slope of 0, that means you're going from either a negative to a positive or a positive to a negative. And that point where that change in sign occurs is where it's going to be equal to 0. For even numbered degrees like 4, you're going to find 1, 3, 5, 7, and so on, all the way up to 1 less than the actual value of the degree that you're dealing with here. So in this particular case, we have a value of 4. It's a 4th degree equation. That means we expect to find either 1 or 3 inflection points. And so that means we're going to have 1 or 3 values of x, y. So we're going to use the power rule for this. So y prime, which is our slope, is going to equal to, well, bring the 4 down and multiply by the non-existent 1. Bring the x and then take 1 less than 4, that gives us 3. And then 2 times negative 8 is negative 16. And we subtract 1 from the x, that gives us there's a 1x, or x to the 1st power. And this is a constant, and the constant is always equal to 0 when you're finding the derivative of it. So this is our equation that we're looking at here. And we know that it's going to equal to 0 to be horizontal. So what we're going to do here is we're going to factor out something out of both of these. It looks like we have a 4 in both of these and at least 1x in both of these. So we're going to factor out 4x. And that's going to leave us x squared right here, minus, and that's just going to leave us 4 there because the x will cancel out. So we get something that looks like this. Now we set, well, first of all, we got to factor the x squared minus 4. That is the difference of squares. So that's going to become 4x times x minus 2 times x plus 2 equals 0. Now we set each factor equals 0, because if you just have 1 0, then the whole thing equals 0. So this again tells us we have 3 possible values for the x. So we have 4x equals 0, x minus 2 equals 0, and x plus 2 equals 0. So over here we divide both sides by 4, we have x equals 0. Over here we have a positive 2 to both sides, x equals 2. And over here we add a negative 2 to both sides, so x equals -2. So now we've done half the battle. Now you can see there's going to be 3 inflection points. No surprise. Now we're going to go to the original equation, x to the 4th minus 8x squared plus 2, for each of these 3 values of x. So y equals x to the 4th minus 8x squared plus 2. And so we plug in 0 for this. So we get 0 to the 4th power minus 8 times 0 to the 2nd power plus 2. So this equals 0, this equals 0, so that just leaves us 2. So that means then that one of the inflection points is the point 0, 2. Do the same thing now for 2. So that gives us 2 to the 4th power minus 8 times 2 squared plus 2. Well, 2 to the 4th power is 16. 2 to the 2nd power is 4. Negative 8 times 4 is negative 32. Plus 2. And this is going to give us that 16 minus 32 is negative 16. Plus 2 is negative 14. So that's going to give us point 2, comma, negative 14. And the last one is to be negative 2. Now, you have to be careful when you put this in your calculator, because if you just put in negative 2 to the 4th power, if I were to put it in like this, the calculator is not going to understand what you mean by that, because you want it to be all of negative 2 to the 4th power, but it thinks you're going to take 2 to the 4th power because it's following the rules of operation, which means exponents go first, then multiplication. So 2 to the 4th power is 16, and then the negative sign goes out, it's negative 16. But that's not what you want. You want the negative 2 being taken to the 4th power, so you must put that in parentheses in your calculator. So negative 2 to the 14th minus 8 times quantity negative 2 whole quantity squared plus 2 equals. So we get 16 for this. This is positive 4, negative 8 times positive 4 is negative 32. And plus 2 again is exactly the same thing as what we have here, only the x is different. So that gives us a third inflection point of negative 2, negative 14. And if you were to go ahead and graph this on your calculator, it's going to look something like this. Here's the point 0, 2. And let's say that this is the point 2, negative 14 here, and this is, or negative 2, negative 14, and this is positive 2, negative 14. And you're actually going to see something like this. Okay? And like I said, these are inflection points here, here, and here. This is going negative, and then positive, and then goes positive, and then negative, and positive. So that's pretty much what happens with a 4th power equation. Sometimes, however, you only get 1 for reasons we'll get into probably when we see them. I'm sure we will. So if you want to just double check and make sure your answer is right, and you use the trace button once you get done. Now, if you use the default mode Zoom 6, it'll cut it off right there. So that means you probably want to increase your Y or change your Y. And say negative 20 instead of negative 10 for the minimum, and then go change your scale to 2. That doesn't really make a difference. But the negative 20 you need to do so you can see the full graph. And then you hit the trace button and see, and it may not give you exactly the points you're looking at, but you get a pretty good idea that what you have is actually correct. So there is a way to check and make sure that your answers are good. And that's just by graphing. Now, the graphing calculator is a kind of a secondary checklist to make sure you've got the correct answers. So if you're curious to know if it's right or not, go to the y equals, punch in the equation, hit graph, have it hit 2d6, and then adjust if necessary like you would for this. And boom, there's your answers confirmed. Okay.